Hello, hello, hello. Welcome back for everyone who could make it back. Well, I'm glad of everyone who is here because this is my 100th stream. I'm so excited about this. It took me 2 years to reach this point, and I'm just like amazed that I was able to actually go through it. My 100th stream. Okay, so excited that you all are part of my 100th stream. Thank you so much. That is, thank you. Thanks a lot. Appreciate that. Okay, so, well, let's make it memorable by finishing up our project. And yeah, so I actually pushed it. Forgot to do that before we ended the session. Sorry. But I've pushed it, so you can actually find the latest code right here. So excited. Like, if I'm able to finish this as my 100th stream, I think this is perfect, kind of. I don't know why I'm excited, but it just feels exciting. It's a big number, I feel. Okay, so there are at least 100 videos with my face on it, each of 2 hours. So 200 hours of content on Major League Hacking YouTube channel. I think that's good, right? Okay, cool. So let's come back. So where were we? We were right here. And I realized that there's so much that I want to do. So I'm going to kind of speed run through it, which is I'm going to paste the code, but I will go through the code. Okay, don't worry about that. Because ideally, what I want to do slash where I want to reach is this point. Let me show you what I had created locally. Like when I was practicing for this session of, okay, this is what I want to show you all. This is what I want to kind of, share with you all how to build something like this. So we have these things. We have this everything. We have all of these. Uh, well, these have a few extra buttons, and I'm pretty sure the income works here. So if I say salary and 3500, random numbers, don't assume that I earn this much. I would be rich if I did. And this is salary, and if I say add transaction, oh no, it doesn't work here as well. Oh, interesting. Maybe. Okay, cool. Okay, that was a flop. Ignore that. Okay, so but ideally what I wanted to show you all is this generate projected earnings. Okay, so this is my actual GBP income, my actual GBP expenses. Not okay. When I say actual, it means from the data that I have, and this would actually create this projected expenses and projected income for next year. Okay, so you can see it will successfully load this CSV data of 1 year, which has 13,000. It will only work through CSV, sorry, GBP currencies. It would like it has like 3,257 GBP transactions out of 13,000. Uh, Aggregate into 12 months, create features, blah, blah, blah. And finally, it will save the model in local storage. So this one I'm saving in local storage. And I'd say like it's pretty near to projected, like the actual versus projected. I think they are like nearly, they're good, comparatively better. Okay, so yeah, this is for 1 month and mm, okay, cool. Anyways, this is the ideal. Yeah, that would be the ideal part. And what else? Nothing else. I guess this is what I want to show. I want to show you exactly like how would you build something like this. That is the aim of this session. So I'm going to speed run through a couple of things, and I'll still explain it. Don't worry. And at any point we lose, we will basically use Copilot to kind of help us go through a few things. Okay, if I'm not able to finish it quickly. Cool. So this is eventually what I want to build. This is not where we are yet. So let's try and get there as quickly as possible. Let me go away from screen. Let's focus on the screen. Okay, so model dot add. Okay, that is something that we have done. And next up is the part where we do a model dot add. Okay, cool. So what's the next step? So the next step is going to be another model dot add, and this is our layer 2. Okay, so in our layer 2, it will again it will use a different activation, which is called as softmax, that converts it to a percentage based outcome or percentage based output. So if I do model dot add, yep, this is good. Okay, so what does this mean? So the way this translates to, remember our room and number of people analogy. So there are 32 people in every room who are reading through the data, and then they are going like, okay, I can understand that the user, like when someone says the word coffee, then it means it is an expense. I can understand that with like some accuracy. Okay, I can understand it with like 78% accuracy. And that percentage accuracy is what this activation softmax helps us. Okay, so it actually kind of converts it to percentages. So yeah, I think that's all I can say. That's the easiest I could think of. So why it goes through every layer, and then at every layer, uh, it's going to say, okay, I think with 58% accuracy I can understand that salary is income. With 98% accuracy I can understand that groceries is expenses. And whenever the user says groceries, they are definitely trying to uh, what's the word, they're definitely trying to use their primary credit card to do it, and they definitely would have bought it from Tesco. So yeah, these are the things. So we can say it with X% of surety or probability is where softmax helps us. Okay, so we'll do that. And then the next one, actually there was a hint right there, but I'll add it again. So not tf, we can just do model dot compile, and let's see. Okay, let me read this. So model dot compile tf dot train dot adam 0.01, loss is categorical cross entropy, metrics is accuracy. Okay, so what does this mean? So whenever a model learns, it's like it is learning, or okay, think of model learning as a software update. Okay, now, if you software update very quickly, which is ideal, then you may end up crashing your system. If you do it very slowly, then you might end up uh, never finishing it. So you need to find that optimal balance of how quickly you want to learn. And that is where this train.adam comes into picture. Okay, it uses this adam algorithm, which has a learning rate, which means that if I okay, think of this as 1% learning rate. Okay, not think of, actually, yeah, it would be 1%. Okay, so if this is 1% learning rate, which means that out of, if you have like 100 data points, that then I'm going to learn it one data at a time. No, this would be 10%. Sorry, I'm going to learn 10 data at a time. Sorry, not 1%, 10%. So okay, if you have like 100 data points, then you're saying that you're telling the model to learn 10 data points at a time. If you increase this to like, let's say 0.5, wait, No, 0.1 would be 10 data points, right? Yeah, because 0.5 would be 50 data points, kind of 50%. So 0.01 would be one data point at a time. If you say that learn at the rate of 0.01, which means it is going to learn at like one hundredths of it. Okay, so it is too slow. This is good. If you go for this, it is very quick, which means it might miss out on learning a few things. So what you're doing is ideally like giving it a learning rate. How fast should it learn? Then we come to the categorical cross entropy. So what does that mean? This is while you're learning, okay, you want to do a quick test of what I learned. What Yeah, you want to do a quick test of what I learned. Okay, kind of. So you want to give an exam after learning like after reading every page of the textbook, for example. And that is where categorical cross entropy comes into picture. It is basically going to uh, give you a test and see how good or bad are you performing. So if you perform like if the output is something like 0.3, okay, that means you are very close to the answer. If the output is something like 10, then you are very far away from the answer. And this is called as the word loss. Okay, so the algorithms, they try to minimize the loss as uh, minimize the loss, yes, so make the loss as small as possible. Okay, that is what the idea is. And the metrics accuracy is basically literally checking how many predictions were correct, how many of them were wrong. So it is properly like accuracy. So it will tell you, okay, you got like, if you got 100 data points, you got 80 of them correct. If you got 50 data points, you got like, let's say 30 of them correct. If it measure it, if it says like 60% accuracy, then it means like out of 100 data points, you only got like 60 of them correct. So that is a very bad model. And remember, 100% is always bad. Like if you get everything correct, then there's something wrong. Maybe someone is cheating. Okay, cool. So that is what these bits mean. And then what do I want to do? I'm just going to paste code now, just to be quick. Sorry about this. Okay, so the next bit is model.fit, x tensor, y tensor, epochs, batch size, shuffle, and verbose. Okay, what do these things means? Okay, so let's think of an example. Okay, simple. Epochs. Okay, let's start with epochs. So epochs are nothing but how many times are you going to study the same page. So example, if I yeah, you're learning from a textbook, and then if you want to improve your accuracy, then you learn the same data. Like you learn the same page, you go through the same page maybe one time, like sorry, 10 times. Okay, so then if you do it 10 times, you have retained more, you have understood more. If you do it like 30 times, like in our case epoch is 30, that means you're going to go through the same data 30 times. You're going to learn the same page on the textbook 30 times. That means you are learning better. If you increase it to 100, okay, then it means that you are learning the same page 100 times. But now it's possible that you actually are not learning anything, you're just literally memorizing every word. So again, with depending on the data, it this you will have to kind of adjust these parameters to ensure that uh, things are not over learning, not over fitting the word, and they are just right. Okay, your algorithm is not memorizing stuff. So that is why literally the word here fit, it checks how fit or how correctly your model will perform, okay, depending on these some of these parameters. Next is batch size. Batch size is, here we are saying math.min 16 and this, so we are saying minimum take 16, and if the length is like less than 16, then take that, so minimum of these two numbers. Shuffle true, which means every time it will try to learn something. So for some reason, your teacher gives you a page on the textbook, you start reading, and then the next time the paragraphs are kind of jumbled, and you have to basically learn it in this new format so that you don't again memorize it, okay. And verbose zero basically means that you don't print out anything during the training on the console. uh, you can have verbose 2, 0, 1 or 2's default is 1, which means something 2 is not implemented yet, okay, do 1. Or we can have 0, which means don't print anything, okay, multiple things right there. Next up, let's see, next up we want to add, okay, this would be good. Cool. So next up, I want to add this evaluation on the test size. So a very quick if condition, that if we have something to test, then and only then go uh, inside this condition. Yes. Okay. So what is this condition and what are we doing? So very simply, we have created a model, and now we want to see how it performs on test data. So you have learned everything, and now you want to see how good you are in your like exam performance, and that is where this comes in. Okay, very very simple. Hmm, cool. So step one, we are saying that okay, there is like this whole tensor 2D thingy where you try to create this like this 2D array of things where you have numbers and numbers and numbers. So there's no words, you only have numbers. This is because the test data that we are going to give it would have contained words, and it's very slow in processing. So we want to give it, convert it to numbers similar to what it has used for learning. So if while learning it has converted all words to numbers or array of numbers, then while testing, why should that not be the case? Correct? Good. So that is what we are doing at the first bit right here. Okay. So that is what's happening in the first bit right here. Then we have the what's it called? The model dot predict. So the model dot predict is going to be the prediction of on the on the test that you have given. Okay. Now remember, this is an array. Okay. So in the array you have given it data, and it is going to mark it for every word, for example. Okay. So example, if you have given it an array, or if you have given it a sentence, for example, if you have given it like buy coffee from Pret. Okay, my data looks like uh, an array where every word has a particular position. Okay. Now buy coffee from Pret, if I read that, then I will be like, okay, this has the word buy. Do I have I learned what the word buy means? Okay, it could possibly mean expense. It could possibly mean something. Okay, so now let me connect it to the word coffee. Okay, coffee uh, normally is expense. Have I learned anything from my seed data where there was a word coffee? Yes, I did. Then if I have seen the word like buy coffee from Pret, there's a word coffee in there. How confident am I that it belongs to the category of exp dash coffee? Okay, so I'm going to mark every category So we have these many categories. I'm going to mark every category with some probability. I'm going to say like 1% chance that it is Tesco, 1% chance it is Sainsbury's, 5% chance it could be AI subscription, 5% chance it could be entertainment, uh, I don't know, 0.05% chance that it could be rent. I am 78% confident that it belongs to this like expense coffee category, and so on and so forth. So I'm going to mark each of them as some percentage, and that is what is going to be used by model.predict to kind of check then later uh, if my predictions have been correct. Okay, so that is right here. Where did we go? Okay, so it is going to wait for predictions array, which will be a number. Okay, this is where we delete it from memory. We delete the test tensor from memory, and we have received our probabilities. Okay, we have received our total probabilities for each category for every test data that you could have had. Uh, okay, cool. So yeah, it's cleaning up our memory, but we have the probabilities. Now let's go and see how correct we are. So step one, first our code needs to know that like for every data that it was given, how many, like what is the correct answer. So that is what we are doing at this point. We are going through each of them and we are saying that okay, like this is the correct answer, this is the correct answer. So we are uh, okay, actually, no. Let's think about it this way. We are actually creating a scorecard. Okay. Like for every category, we're creating a scorecard to see like how many did you like did the student, let's say in this case, how many did this how many answers did the student give correctly versus how many were the correct answers. So if the user says, like if the student in this case says that, okay, I got 20 questions and I said that there are five of the questions whose answer was expense coffee, how many did I have actually, which would have been expense coffee in like in my real like in the test exam, how many of them were actually expense coffee? Maybe I had seven and the student said like no, there were five that were expense coffee. Then we can calculate uh, what is their accuracy. If they say if I only had four and they said five, then again we can calculate the accuracy. So how many did the student get correct or wrong? Well, correct mostly. And how many like expense coffee existed, for example. So that is what we are going to do in this, like that is what we are doing here. Okay, we are creating a scorecard, a record of two things. Cool. Now TP means the word true positives, okay, which means how many of these were predicted correctly, and total, of course, means like the total samples that belong to this. Okay, so how many of them were predicted by the student versus how many were the actual right answers, if that makes sense so far. Cool. Now let's do the comparison. So this is all about doing the comparison. Uh, so we are looking at each of them. We are checking how many were actual correct, how many did the students say correct, which has the highest value. Okay. So the best value is what matters, because remember our model actually says that like gives a number to each of these categories. So when we give it the word, like the description, coffee at Pret, for example, it would have given like every category some number. But what we care about is which category did it give the highest score to, because that is what our model was very confident about. That I'm like 78% sure that this is uh, expense coffee. So that is what we really, really want, which is what we are doing here. Like we are going through the array, and then we are saying that find out which one is the highest rating that they gave. Now assume, like, what if for like coffee at Pret they said that I'm 78% sure that it is expense dining, or like 98% sure that it is expense dining. So this means even if they gave 78% to coffee and they gave like 98% to dining, this is going to pick like dining as their best value. Okay, so this will tell us that okay, the model is not that good. Student our student is not good, our model is not good, or whatever you can think of it that ways. So in this case, in this part of the code, we are basically checking like what is the actual answer. Then we are checking what is the student's best guess, and if they match, then it means that uh, like student scored 1 point or they got it right or whatever you say. If it is not matching, so if the best guess does not match the actual answer, then of course the student lost it. Okay, cool. So yeah, that is this bit. And right here we are saying what is the accuracy of the model. So we are saying in this case how many of them are the correct guesses divided by how many were the total questions. And if let's say we have 20 questions and you got like 10 of them correct, then 10 divided by 20, that's what we are going to do, which would be 50% accuracy. If there were 20 questions and you got like 18 of them correct, then 2 nines are 18, 2 tens are 20, 9 by 10, 0.9, 90% accuracy. Okay, so yeah, so this is like little math, and then we are just printing out a few things. Hmm. And finally, what we could do is just save this model to IndexedDB. Okay, not really needed because we can like keep on recreating it and keep it in memory or something. But for the time being, I'm going to be very basic and like kind of show how to put it in IndexedDB. Cool. So we have created our model, but we need to use it somewhere. So the place we are going to use it is transaction form. So in transaction form, I should have a handle generate model. Nope. Do I have projected field group styles dot action? Okay, perfect. So field group. Hmm. I'm going to give this an on click and I'm going to say that you are going to return a handle suggest category, and then for the demo model button we are going to have another on click, and I'm going to say that you are going to return and generate demo model. Cool. So these are two functions that we need to create. So let's quickly get into it. What's the time? Okay, time to copy paste. And we'll generate model. Where do I put it? Let's put it right here. Perfect. I will need two use state variables. This is one, and this is the other one. Okay, so these are two use state variables that we'll need to use. Cool. So very simply, the function, all it does is it is going to generate and save demo model to index.db. Uh, and once it is finished, then it will just show an alert. If there is an error, it will show some errors, and finally it will set the generating model to false. So while it is generating, there we go. So while it is generating, then in that case, it is going to basically, why is it unhappy? Cannot redeclare. What do you mean read? Oh, it's already there. Okay, my bad. I had added it. Nice. Then I think the setters need to just be moved away from underscore variables. Perfect. So yeah, all it does, it first, like, it will show a text of generating for some time while it is, like, sorry, it will show the text of building demo model, and when it finishes, then in that case we set it back to false. So in the finally section we are setting it to false. So when it becomes false, this condition is false, then the else condition comes in and it says create demo model, demo AI model. Okay, now let's create the handle suggest category. Oof, this is going to be lengthy one. Let's see, I can just put it right here. Why is it unhappy? Oh, because, well, this doesn't exist, right? Okay, so we'll need to create this one. Suggest category. Oof. Let's quickly create this. I have inside the ML folder, I can create a categorizer.ts. Okay, so let's first look into creating this code. And once that is done, then we will try and understand the code. Cool. Mhm. not have. Oh, yeah, here we go. And this is going to be a bit lengthy, but just like bear with me, please, for a second. So I have this, which is going to be this, and now this one is going to call the load categorizer model, which is going to load the model. Okay, pre-process should exist. Nope. Well, definitely pre-process exists, right? We created one in this. Where is it? Pre-process. Oh, it's not exported. Oh, that's why. Let's go in and export that very quickly. Export function this, which goes into this one. We need to also create a do I really need to do all of this? Hold on. Let's think. What do I want to do eventually? Okay. So what I'm trying to do is I'm trying to create a model. Let's say I don't do the suggest first. Let me first create the model and show it to you. That would be easier and nicer. So let's go into this, reload everything, clear everything, add transaction. Okay, step one, let's see what our model does. So if I go into the application tab where we will actually save the model, we only have the finance tracker DB and it has three things. Okay, cool. Now, based on all the transactions that we have had, let's click on like this create model and create dataset sizes, total 45, train size 36, and test size 9. So it is going to do this on like 45 data, correct this, and 9. Okay, so from the 9, it made 6 correct guesses. 9 of them were the total, so accuracy is like 0.6. Let's see. Per class, how many of them were accurate? Okay, cool. And save the model in here. Now, one thing that I want to quickly check slash show is what if I do the verbose logging to 1. Okay, now let's do create demo model, and there we go. But let me delete the previous one. So we are going to be stuck with this, unfortunately. Okay, We're going to be stuck at like 66% accuracy, unfortunately. So I think that is fine, I guess. Uh, the only concern that I have right now is why is the total stuck at 45? How many data points do we have actually? Let's go into our transactions, create demo model. So they're 93 and end up with 45, which is very interesting. So there are a lot of things which have categories set to null. Yep, 45 of them. Okay. Uh, why is the category null for our data? There's another question that I have right now. Oh, not null. It's not in the list, basically. Okay, so that's my bad. Should add more. Tesco, Sainsbury's, AI, entertainment, rent, coffee, salary, utilities, gym, dining. Yes, the only last thing that I want to do is some investments bit. Can also go in here. Coffee is already there. Expense lunch can go in there. Hopefully it's not repeated. Perfect. And expense travel can go in there. And possibly expense utilities water can go in there. Expense transport public can go in there. Expense subscription mobile. Okay, so now we should have more data, ideally, to train. So let's go into our transactions, clear it out, create demo model 93 to 66. Okay, this is good. And now we should have more data. And accuracy decreased. Oops. Well, that's bad, right? So now our accuracy is 50%. Well, it was better with 66, but now it has decreased to 50. Okay, so we'll need to experiment with a couple of parameters here. So let's see, what can we experiment with? What if we say that instead of 32, you have 24 number of neurons? Okay, and epochs, I say like instead of 30, you do 40. Okay, let's see what difference it makes. So let's create a demo model 93, 66, train size, test size. We are learning a bit more, and the accuracy increased. It increased to 57%. Okay, so we are, I think, if you try and kind of change things around a bit. So what if I increase the number of neurons to 45, for example? Mm, okay. So we have increased the number of neurons to 45, and let's see how it affects our this one. Okay, that didn't help. The number of neurons increasing brought the accuracy down again. So, well, that's not a good idea. What if I reduce it further? The number of units is 12, and I actually take the learning rate down as well. Okay, so we are doing learning at 0.01. So we're learning more slowly. And that actually degraded the accuracy further. So that's not good. Uh, let's experiment again. Number of neurons, let's take it up to 32 once again. But let's keep our learning rate way low. Okay, nope, that is not good. Uh, 32 in the epochs, same as the number of neurons. And at a time, actually learn 10, for example, 10 things at a time and do it 32 times. Mhm. Okay, not helping. So what was our best? 57% prediction, I think, was the best so far. 30, 24. Let's see. Mhm. Maybe I should kind of decrease a few things. Hopefully, I don't have any repetitions here. Mhm. Okay, we are not improving our model, at least with the amount of data that we have. It is not really helpful. Things that we could do, even like at this point, is increase the number of data. Of course, if we can increase the amount of data points that we have, that would be ideal and helpful. The vocabulary, if we can have a few more words in our vocabulary, that should help. What else? Let me see. Okay, you know what? Very quickly, what I would like to do slash want to do at this point is pass this over. Let me see if I can pass it, but I'll need to log in. So give me 1 second to log in to Copilot. Let's see if I can pass it to Copilot and ask it to generate more data, which will help us improve the accuracy of our model because we'll give it more data to kind of work with, right? So let's do that very quickly. Okay, I am logged in. Let's go in here. I can give it this. Increase the seed data. Why is this unhappy? Okay, let me remove this. Increase the, and also remove the, oh, sorry, let me leave them be debug, and this is also debug. We want to increase the seed data and the demo labels, and demo underscore labels, comma, demo underscore vocab. Increase the seed data to 150. Wait, which data we want to increase the seed projected transactions to 150, and demo labels and demo vocab to match seed projected transactions. Let's see how this goes, right? Let's see how this goes. Okay, it's trying to understand it, which is nice. And then it is going to add more data. So I'm waiting for it to add more data to kind of go through that whole process of, okay, this is what happens, and this is what we do, and this is what it would look like, all those things. Just bear with me for a second, please. Okay, perfect. So let's see. We keep this data. I'm going to close this. It has added some. Okay, it has not. Let's see. Let's go to our transactions, reload, clear all of it. Transaction and create demo model. So out of 237, 190 of it usable, train size 152, test size 38, and let's see how this one performs. Okay, done, and 100% accuracy. Really? Well, that is bad. So let's see what happened. It actually created all the labels. Okay, which is bad. So let me increase the number of neurons to 32. Well, this is all fine. Epochs like 24. And let's see. 190, 152. Well, this in this one, yep, it is going to cheat because well, it has created labels for everything. I know, right? So maybe I should ask it to only increase the data, right? Increase it to 200. Maybe that would be ideal. Increase the seed transactions. Wait, where is the seed transaction? Is it? Oops. Well, well, well. I think that's the culprit. It is not inside the array, right? I have no idea what it has done. Things that I can't trust. Okay. Let's try to be smart with it. Okay, that is the problem. Let's try to be smart with the generation of data, which is bad. Should not have been. Okay, ignoring that bit, let's go back. Sorry, that is my mistake. Should not have asked it. And generate save model. Oops. Now this also has some of my changes. So I'm going to do Control Z until we reach the point. Yep, right here. Okay, this is where we were. And now we'll be back to less data, sadly. But at least it's more understandable accuracy. Right? Perfect. Now the suggest. Okay, let's go to the suggest. Let's see how good our suggestion is. So suggest category, I was creating it in the categorizer, and I realized like what I can do is just copy paste everything. So I've merged all of it into a single file, and here would be my categorizer. The only thing is that the labels should basically match with what I want here. So if I take these demo labels, that is what should be here exactly. I should remove stuff that, like, after adding some of these, our accuracy has gone down the drain. So I'm going to remove a couple of them, and let's see how well it performs as the model. 45, 36, and 9. Okay, 66%. Uh, let's be happy with what we have. That's all I can say at this point. So these demo labels, I can just export it. Why am I doing all this? Export, and vocab, just export. And there we go. Demo vocab gets imported from here, and demo labels get imported from here. Okay, so what are we doing? We are doing exactly what we had done before with respect to like the pre-processing and stuff. It's kind of repeated functions. They were created at two different times, so that's why the repetition. But for the timing, just presume like this is what exactly we have done before, so that's fine. That's fine. Load model. This is loading a model from this particular location. That's it. And suggestions, now depending on what the user has typed, that would go as an input to this function, which will then step one, it will try to make it very similar to what it used for learning, which is remove all the punctuation marks, convert the capital to lowercase, and ensure that it gets an array of whatever is needed. Then it converts to like, goes to the bag of words for the tokens, then converts to it to a tensor. Then it gives it, uses the model, okay, the loaded model. It uses that loaded model, passes it the input, and waits for it to come back. Then it say checks since the model is going to basically give a percentage value to each category, again it loads what is the best one, disposes of the data, and then from the demo labels it tries to find the best index. If it found the best index, that is what it is going to return. If it didn't find it, then in that case it's going to return empty. Okay, and then if there is any error, it's just going to ignore everything and return an empty string. We are going to use this in transaction form, which is unhappy because it's not imported. So whatever the user types as an input, like in the description, that goes into this, calling it categorizer ID. It's called cat ID. So no suggestion available. If there is a suggestion available, then it basically applies that in the category and set category. Whew. Moment of truth. Create demo model should be 66% accuracy. Okay. Uh, and now if I do grocery Tesco and I do suggest AI category, it should fill the categories and subcategory. This is the only thing that would work. So if I do Sainsbury and then I do grocery and suggest, then it goes subscription AI tools. Let me go away from screen and you can see it. It thinks, oh, Sainsbury's must be subscription. And if it's subscription, must be AI tool. Well, it failed, unfortunately. What about if I do Tesco grocery and suggest? Then it goes like, Tesco grocery Tesco. Well, I know what it is. So yeah, that is what we have created right now. If I do just Sainsbury, it understands, which is very interesting, right? So this is our first model, which is pretty bad, I would say. We don't have enough data. We did not train it on enough data. We did not have much testing data. We tried to use Copilot to kind of get more data. Well, it cheated. So yes, you were right. It did cheat. Like the model just cheated, which is bad. But okay, this is where we end up with, very simply. Uh, how can we improve it? Number one, increase the number of transactions. Even in the seed data, if we can increase the number of transactions, that would be ideal, which is the next thing that I'm going to do. Then after that, once we have increased the number of transactions, we can, what's the word? Play around with some of those parameters. So we did play around with some of the, like actually all of the parameters that were configurable. No, sorry, some of the parameters that were configurable. And it didn't help much, especially because we didn't have too much data. If we could have had too much data, then I think it would make much more difference. Okay. So which is where the next bits come in. So in the public folder, I'm going to create a data folder. Inside the data folder, I am going to paste uh, two files. And I'm going to push this right after so that you have this exact thing. So seed merchants. Let's start with that. So this is some merchant names, like 56 merchant names right here. Aldi, Asda, Sainsbury, Amazon, Costco, John Lewis, Primark, KFC. Well, I've never been to KFC. I'm vegetarian. But okay, so that's how you know that this is fake data. Okay, this is fake data because, well, step one, never been to KFC. Okay, then the transactions, these go in here. 13,000 transactions is what I have. And at this point, I think it is good idea to push everything. So git add all, git commit session 6. We actually added added generate demo model and suggest AI category and git push. So you can get this data by going to GitHub and getting it. Okay, so next up, we are going to create, like, just get all the data from there. This is the link to get all the data that you need and everything. Okay, next up, we are going to create this new file in source ml projected data.ts. Okay, well, actually, projected, not projected data, projected, no, projected data. Yep, that sounds right. Cool. So step one, let's import TensorFlow.js. Okay, so what are we going to do? So if you remember that chart from like moments ago, we saw that I click on a button, generate model, which generates a model where it basically tries to, what's the word? It tries to take a look at the CSV file, get all the data, and takes my income and expenses, and then based on that previous income and expenses, it shows the next income and expenses, like my predicted income and expenses. So that is what we are going to build very quickly. In the amount of time that I have, I'm pretty sure it should be fine. So some types for the time being. So CSV transaction. So each CSV transaction in this looks like this. Let's see if I can close this, and if I scroll all the way to the top, so we have ID, date, type, category, description, amount, currency, merchant ID, merchant name, blah 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 blah. Okay, so I hope that it makes much more sense. Our monthly data would basically be a subset of these things. There is one thing that I want to quickly check though. So we have GBP 3257. How many euro? 3262. So if I can make like a lot of euro as GBP, then we'll have more GBP data. Okay, not all of it. So I don't know how we can select like next n uh, options. Like I don't want to select all 3262, but I want to select like, let's say, half of it. Okay. Uh, so if I convert this to GBP, no. Okay, that is bad. Simply now have given up. I can do replace, 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 replace. I hope, well, it didn't. Does anyone know? A quick question to the chat. Does anyone know how to replace next n occurrences? So instead of, yeah, replacing like this, I want to replace next n occurrences. Okay, I got bored. Sorry. So now we should have more GBP transactions. 6519, nearly half of the total transact. Yeah. So if I go to, like, let's say this point, after this point, if there is any GBP, I want to convert that to euro. Wow, that's a lot of GBP transactions now. Okay, the reason why I'm doing this is because I'm not going to uh, have prediction created for every currency that's out there. Like, we have a lot of currency in our data set, but I want to keep it simple. Okay, so now I've done. Okay, this is good. 6,000. That's less than half. Perfect. Projected would look something like this. Projected result would look something like this. So all this is basically the types. Excuse me. And while everyone was on a break, I asked Copilot to add comments to my code, and I hope like the comments are right. I read a few of them. Okay, don't worry, and they looked right. So I guess this is good enough. Okay, cool. So there we go. So what have we done so far? We have said like these are the types of our data. We'll have a CSU transaction of this type. A monthly data would look like this: projected monthly data, projection result. Parse the CSV. So this is code to parse the CSV to skip some details. Headers for each of them, create some like the title, and then for each of the value in the file, this is like assign it to this kind of object. Okay, the first one is ID, then date goes to date, blah blah blah. So that's what's happening in the parse CSV. Load CSV is going to load it from slash data slash file name. Now if you're curious why slash data, it's because if I go to localhost 5173 slash data slash a file name, let's say seed transactions labeled .csv, I should ideally see it right here. Okay, so because that is where what do you call, that is where, so in a public, anything in public folder is served directly on the forward slash, like the root path. So that is why you would get it there. Next up, we want to create an aggregation function. Okay, so why do we need to create an aggregation function? So that I can basically, instead of, so all my transactions are spread over a few days. Okay, so they're spread over, I don't know, a year. But when I make the chart, I don't want to, what's the word, I don't want to do it like for every day. Of course I can't predict for every day, I can't predict it for every year. So I'm going to predict it like per month basis in a way. So that is where aggregate comes in. Next up, my currencies. So what I'm going to do is filter by currency, where this is going to basically return uh, what's the word, it's going to return GBP. Yes, that is what's going to return. It's always going to return the GBP. Next up is, excuse me. Okay, next up is going to be some feature engineering. Okay, so feature engineering, it is the process of basically converting any raw data into like numerical data. Okay, we have done this, but what the word for it is called feature engineering. So example, what we are going to do is, so this is what I had done, and this is what Copilot has added as comments, which I think is mostly correct. uh, Here we go. So number one, the first feature is going to be normalized month. So we are going to capture any seasonal patterns in my spending. Example, during, let's say, Christmas, I spend more than like normally. uh, so any long term trends, example, if salary has increased over a year. So my data itself is not exactly in the format of January, then February, then March. It's kind of haphazard. So that we have sorted by doing the aggregate by month. And now between the data, we are basically checking if there has been trends, and uh, we are kind of making some numerical numbers around that. Okay, so that is my features. Moving averages of last 3 months, it will help the model to understand any trends. Example here, as it says, so it will say that, okay, let's see, Jan to March, then Feb to April, then Feb, March, April, yeah, then March to May, then thing. Okay, so that is a moving window. And now comes the build model function, and that one is going to be very simple. Okay, so that is what it has, like the model. So again, sequential model. You can actually experiment with a lot of models that exist here. Okay, I'm going with sequential for the time being. So input layer 4 features, output 16 activations, good initializer for ReLU. This is something that we have not done before. And then we have model.add, again model.add linear, so on and so forth. Like too many of the things that you can experiment with. And finally, we should have the train model function. Where is it? Okay, not finally. Training the model. This is where we train the model. I think Copilot has done some really good work around logging data. And after training, we need to, uh, not logging data, sorry, adding uh, comments. Okay, generate projections. That's the next one that we want to tackle. Okay, I'm now, how much time do I have? 45. Okay, won't have too much time, but I want to finish this. So I am going to first put everything in and then take it from there. Okay, I need historical yearly data. So excuse me for a minute. Once I build this out, then it would make life so much easier. In the dashboard, I want to quickly add a few things. Whoops. Okay, what I'm trying to do right now is basically reducing the scope of it so that I can quickly show it to you of what to do. Let me try and, okay, what do I want to do? I want to get the dashboard. which is inside my components dashboard.tsx. Okay, well, I'll also need to create a new chart, a yearly chart. So let's start with that. Yearly trends chart.tsx. Okay, a lot of problems, but let's fix them out. So, well, it needs all our imports. It needs some exports around a few things. Now, what am I missing? I shouldn't be missing anything ideally. Let's see, functions to create a few stuff, some types. Okay, there we go. Perfect. So yearly trend chart is ready. Uh, Very simply, if I have to explain this one, then what we are doing is creating a line chart. Okay, the lines that you would now see on the screen after this, that's what I am doing. Projected expenses will have some lines, projected like actual expenses will have some lines, so on and so forth. So very simple, I would say, in terms of like the work, the stuff. And to show it on screen, I can go into the dashboard.tsx, and right above all the charts, I can put it right here. Yearly trends chart comes in here. The problem is the data, right? Not the problem, but what is missing is the actual year data. I can basically put it somewhere. Okay, now who is unhappy? Oh, historical data. I can put you right here, and historical yearly data is right here. Need to add a setter for it. Okay, so I need a button first. Oof, a bad idea. Always bad idea. Do things up quickly. So let's see. I think I'm nearly there. Okay, perfect. So what am I left with? Projections, and it's generating projections. All of this can technically go into state, which is right up top here. Now, what am I missing? That's fine. Projection result can be imported. Now, generate and save projections can be imported. What else? Load historical data can be imported. Now, who's unhappy year point? Yep, you can be imported. Perfect. Whew. Nice. Right on time. I have like 9 minutes to go. Okay, so what do we have here? Well, simply I'm going to create the chart. Yearly trends chart is just the chart similar to what we have done before, with some title and like total like colors to kind of tell what is which, like which is which. This function, the projected data function, this one is interesting because we have done exactly the same thing that we did in the demo model, but by reading from the CSV file. And there are comments explaining each and every bit of it. Let's first test it out, and then I guess I'll push it and then we can take a look. So now it is generating model, training, loss. How much is the loss? Okay. And finally generated. Okay, let's go. So the actual income and the projected income, if you see, they are quite close to each other. The actual expenses versus the projected expenses, that is where it is. And it has loaded the data from this file, 13,000 transactions. Out of that, it filtered out for 6068 GBP transactions over like X number of epochs. Okay. It has its loss is decreasing, which is good, which means it can predict better. For over 3 months, this is what it is going to look like with respect to like in the first month the income and expenses, second month income and expenses, third month income and expenses. And all of that data is actually going to be stored in the applications local storage. And here you go. This is the prediction per month. The chart is seems to not be rendering at this moment, because ideally what you would see is not one straight, like not two straight lines. You would want to see every month what the chart looks like. So I'll fix that after this. uh, but I'll push what I have right now so that you can have a look at it. I'll try and use Copilot to kind of add more comments explaining stuff and plot every month. So that is the end of this one. Added yearly prediction chart and git push. Okay, how much time do I have? Well, less than 5 minutes. So step one, I'm going to ask, like, share the feedback link, and while you have that with yourself, I will, like, let's quickly go through like most of these things, like parsing, loading CSV file, aggregating by month, and filter by currency. This is fine. Creating the features is basically a feature engineering part, I would say, where we have kind of tried to get some important features for our prediction. Like if my salary is going on an increasing trend over the months, then definitely I'll have more income next year, or like previous year. So this will, like, these are the things that you would give your ML model. You'll, like, these are the things that you tell your ML model that are important. Okay. So then when you train the model, it understands these features and tries to give priority to each feature. So this gives a priority to, like, okay, if like let's say income labels are very important, give it like more priority over something else. So that is what is doing. That's why we create the feature labels. Generating and saving the projections are just putting it in the local storage, so ignore that bits. uh, Aggregate by month, training the model. Now the only difference here, not the only difference, but one of the major difference here is about what we use to train the model, all the algorithms that we use to train the model. So they are similar but not exactly the same. So example, where did we go? Yeah, right here, when we build the model example, sorry, not train the model, build the model. In that case, we are saying that these are our four important things. Train six, like use 16 neurons to train Activation is this one, and there's a new thing called kernel initialization, which I don't have time to explain. Like, again, we do a second training and we reduce the number of people who are learning, number of students who are learning. Then we do a third layer, which is the output layer, which will do a single value prediction if it is an income or expense. Like, given a data, predict if it's income or expense. Metrics, again, we can go to accuracy as one of the metrics and check out for like what that looks like, so on and so forth. So I think the suggestion would be, like, please do try it out and see what it does. So, well, loss would not be mean squared error, it would be something else. But yeah, this is where we kind of end our session. Oh, thank you so much. Okay, cool. I guess that's the end of it. Here you go, folks, for any feedback that you have. This was the last session, and yes, this was my 100th stream. Uh, all the code is pushed and it's still training. So let's leave it for a bit. I will add more comments and then I'll push it again. Okay, so that is the end of our sessions. The UI is up and running, like it's working. Just increase the number of data, like the data that you want to add there. Yeah, there we go. Well, this is good, right? Actual income, projected income, stuff like this and stuff. Okay, and yep. Okay, that's all from me, folks. Thank you so much for listening, and I will see you in next Global Hack Week. Next up, enjoy with Jocelyn, who's here about how AI sees Intro to Computer Vision and YOLO. Cool. Over to you, Jocelyn, right after this. Thanks. Cheers. Bye bye, everyone.